One of the places that you're going to find exponential notation used a lot is in scientific notation. You'll see this in your physics and chemistry classes, and certainly in engineering fields and so on. Well, we just want to have an exposure to this. A standard notation is just a number written the normal way. Now I want to start out by looking at a really big number, like 53,000. Okay, it's a big number. In scientific notation, this is standard. In scientific notation, all numbers fall between 1 and 10. They have to be greater than 1. They have to be less than 10. Well, what that means is all numbers in scientific notation have their decimal point just to the right of the first non-zero digit. This would turn out to be 5.3000. You can see this is 5 something, so it is a number between 1 and 10. Now, these are not the same. I would have to compensate this by multiplying it by a power of 10. Well, what power of 10? If I moved the decimal point, let me do it in red. The decimal point started out here. If I moved it 1, 2, 3, 4 places to get it here, I was making it into a smaller number. I will have to compensate by multiplying by 10 to the 4th. Every power of 10 moves it 1 place. So 53,000 becomes 5.3000 times 10 to the 4th power. I won't write those zeros after I've moved it, so it will simply be 5.3 times 10 to the 4th power. Big numbers in standard notation turn out to have positive exponents. All right, let's look at a small number, like 0.000652. That is a very tiny decimal number. In order for it to be in scientific notation, the decimal point would end up being here. To get there, I would have to move it, the decimal point, 1, 2, 3, 4, 5 places. So in scientific notation, this would be 6.52 times 10. Because it was a tiny number and I made it big, to turn it back to a tiny number, I have to multiply by a negative exponent. 1, 2, 3, 4, 5. Okay, if the number is tiny, then the exponent will be negative, because what does a negative exponent mean? It says, move me down. If this moves down, then you would be dividing this by 10 to the positive 5, which would make it back to this number. Now, that can seem like a lot to remember, but here's what you need to remember. All scientific notation has the decimal point after the first non-zero digit. The power of 10 that you need depends on how many places you move the decimal point. I do not encourage people to memorize right and left and so on. Instead, just remember, if it was a big number, count the number of places, it will be a positive exponent. If it was a tiny decimal, count the number of places, it will be a negative exponent. Let's practice. All right, the first number is 79,000. I'm not going to put the comma in there right now. And it does say to use the multiplication symbol in the math palette as needed for the times sign. Okay, what will this be? The decimal point has to go here. It is right here. So I will have to move it 1, 2, 3, 4 places. In scientific notation, this will be 7.9 times 10 to the 4th power. and it's positive 4 because that was a big number. So I moved it 1, 2, 3, 4 places. I put it as 10 to the 4th because it was a large number. The next one is 0.00000173. I hope I copied it. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay. To write this in scientific notation, the decimal point will have to go here. That means I'm going to have to move it 1, 2, 3, 4, 5, 6 places. This number will be 1.73 times 10 to the negative 6. It's a negative exponent because I moved it 6 places and because it was a tiny decimal number. Big positive exponents, big numbers. Negative exponents, little decimals. Next one, 0.00013. In scientific notation, the decimal point will have to go here. So that's 1, 2, 3, 4 places. The number would have to be 1.3 times 10 to the negative 4. Why negative? Because it was a tiny decimal. Negative 4 because I had to move it 4 places. The last one, I have 1,680,000. I'm not putting the commas because they'll get a little confused with other things. In order to put this in scientific notation, I have to have the decimal land here, and it will start here. I will have to move it 1, 2, 3, 4, 5, 6 places. This will be 1.68 times 10 to the positive 6. 1, 2, 3, 4, 5, 6. Positive exponent, standard form, big number. Negative exponent, standard form, tiny decimal. Okay? In our next lesson, we'll be going backwards.